Hello, and welcome to a rather short stream here at the end of my day, at least. What I'm gonna do here is start implementing a bit of post-processing. We're gonna start out with tone mapping, and for that we're gonna we'll create some post effects pipeline with a pipeline state object here. And we'll probably do a what do you call it? Yeah, we will start out by building a postfix series of pipelines here. Postfix pipeline, pipelines. Right now we will create one. Let's do a type diff unsigned int DX12 pipeline postfix pipeline type. Let's do the enum here, dx. And let's do a tone map pass through. Okay. And we will use some of this stuff here. And let's leave this and let's do post FX pipelines. Lines here. And let's do something like tone mapping. And let's do this. Can I actually do a draw call with an empty buffer? Oh, whatever. So instead of doing this, we do a postfix pipeline here. And let's do our and let's do our enum for that. Oh, we of course need this. Okay. So the pipeline is something that we want to initialize, but for these void initialize post fx, and let's do this, and let's do a vertex shader directory, a pixel shader directory, we probably want the input details. Or do we even want that? I don't know. We probably don't need it. I don't know. Let's check if we can do it. Root signature preset. With root signature. And let's create a root signature here. And let's start out by doing that. So let's copy some of this stuff here. Let's create an empty description. Did we build shaders, blah, blah, blah. Okay, it's actually above us. Okay. Root sig raw pointer equals p root sig. And build shaders. Let's do this. So let's do a vertex shader directory here and append it with that, and then initialize the vertex shader, and then set our path to the pixel shader directory. It should probably be called this. Yeah, basically it should be below it, but it doesn't matter. And let's initialize the pixel shader here. Pixel shader. There we go. And let's do this pixel shader here. Compile pixel shader. Compile no, that's vertex shader. Pixel shader here. Okay. Let's set our rasterize mode, fill mode, solid. Oh, I didn't mean to clip it. Back. And let's see. Let's do this. Let's do this. Let me think. We should probably not do any depth testing here. Can I do format unknown? But we won't be using it. But it doesn't really matter. This should be, let's see, what's 0 unknown? Yeah. I think this should be fine because it will all be set to 0. Let's see. Our primitive topology here should be triangle here. Number of rendered targets should be this one. Yeah, we can always change this. Okay, let's create this. And let's create this. And let's see how many errors we get. Let's see. This should be fine, right? Yeah, of course I need to do some stuff, but initialize post effects. Okay, also need. Let's just do the standard root signature for now. We don't need the topology, I think. Yeah. We will hard code it. I mean, the topology shouldn't be something that we consider in a post effects shader because, I mean, we're kind of like supposed to let's create a post effects folder here, and inside that we will actually create a standard vertex shader. And then we will add some tone map pass through. Pixel shader. Yeah, let's try that. So let's see shaders post effects dot vertex shader dot a. No, just like that. And then post effects slash tone map pass. Okay, let's see how many errors we get. Shader loading error. Let's see. What's the okay. Didn't we actually do anything? Well, we did. This should be fine. I mean, right? Maybe not. PS directory, shader. Oh, of course, shaders. Okay. Oh, yeah, of course. So the first problem is that we haven't set our root signature, of course. The vertex shader expects. Yeah, okay, I need to create the input assembler then. Let's do a const input details here. Add that. Okay. And let's add the code for that. Let's do this then. Input assembler stuff. And let's do a vertex data here. Okay. Let's see, shaders, root signature, and shaders. Okay. It's probably not satisfied since it's empty, but yeah, okay. We need to supply the pipeline inputs here. Yeah, we're still in trouble. Yeah, but we will just create a or provide a series of what do you call it? Vertices, positions. Doesn't really matter. There we go. Okay, what's the problem now? H result is what? Uh, okay. So what's the actual problem? Okay. Let's see what's bothering us here. So we do load our shaders, but we have a crash. Are we missing some values or? Let's see. Do we not get our H result value anymore? Did we mess this up? Did we mess this up when we changed the maybe we don't want the throw. Let's try disabling the throw. Okay. Okay, that's not the problem, I guess. Is it? So it's not, probably not the thingy? Is it because Let's see, message. Let's try removing this for now. Do I need to clear it? No, I already did. Well, so we set the root signature, which we pass in. We build the data here. We fill out the rasterize state. Got this. Let's see. And we do set the topology. We set sampling. Do we need to set a blend state or what? Or did we already do that? Yeah, we did. So that's not the problem. What's the problem then? Is it because maybe our vertex shader here doesn't understand? No, it might. It knows it takes a position, so shouldn't be the problem actually. Huh? Okay. Let's see. Yeah, so it's related to some of the semantic name cannot be null. Okay, so position. Is it the problem that we don't have? Let's see. Oh yeah. Oh, it doesn't match. Input. Let's do a float for input, and then this. Dot position. There we go. This is probably it, right? No, we still have a problem. Semantic name cannot be null or a pointer is corrupt. Okay. And when we do it up here, we pass in the pipeline inputs. Huh? 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 Well, how come that is different? Did I mess something up? Oh, maybe, I don't know. Maybe it's because it's in a scope or what? Maybe. Oh yeah, okay. Yeah, okay, that data needs to be intact. So like this should still compile, run, whatever. Yeah. Okay. So we're basically good here. So now we can compile a postfx. Um, um, a postfx pipeline fairly easily. The postfx thingy here is basically going to be well, this doesn't really matter. Vertex index, and let's do sv vertex id, and let's do a struct vertex shader output. And let's do a load floor pos cs sv position here. and a float 2 UV text coordinates. And let's return a vertex output here. Vertex output, output. And let's return that. And let's do the float to UVs. Float vertex index bit shifted 1, and oh, this is the first one, and then the second component and with and 2, and then vertex index here with an and 2. And let's do output UVs output that position in clip space equals a float 4 with our UVs dot x times 2 minus 1, and the negative UV y here times 2 plus 1, and then 0 for the depth, and a W of 1. There we go. And there we go. Let's see if this runs and compiles. Okay. So we simply create our post effects here. Yeah, and for this one, let's see. I guess we would want a I think let's create a root signature for it. Not here, but here. Let's see, we do the root signature stuff. Debug. Let's do regular debug. Post effects. Yeah, okay, we already have 3. And when we create a root signature, initialize here, let's close the sample stuff. So let's do else if here, preset equals 2, and let's just change this to 3 and swap this, and let's do this. To preset to post effects. Yeah. So let's do that also when we bind it. This is debug, so there we go. And this should still compile. Okay. Great stuff. And bear in mind that everything is on purpose here in terms of the extreme visuals. So let's see, let's do this, but instead we do, and of course we need to do like this. Static samplers equals maybe so far 1, and these static samplers we want 3. Let's do a SRV shader register 0, original rendered image. Let's do another SRV here. Second rendered image. This could be, for instance, for Bloom. First. There we go. And this should be fine, right? Yeah, we're good. Okay. Then we want a postfix pass void render postfix pass. Let's see. DX. What types do we actually have here? Postfix pipeline type. Postfix. Okay. Let's do like we do postfix pipelines, and let's do a postfix pipeline pointer here. Okay. We don't want to do that. Let's do a actually let's do exactly what we did here, but instead of doing this, we will do opaque. P opaque. It's because we will use the different stuff here. We will bind the root signature. We will use the opaque. Oh, let's just use the usual topology. body 3D, primitive topology, triangle list. And then we set the vertex and index buffers. And that's why we use the opaque one. And then we actually do the same thing as we do in our render to texture, except we don't change the scissor rects and stuff like that. We don't change the render targets either, but we do change the current do we need an intermediate? I'm curious whether I'm allowed to actually render to it. Right now we will just do this. So right now it should simply do a color right here for the whole screen, right? I'm pretty sure that's what's supposed to happen. Okay, so we do the skybox, debug render pass. Maybe we allow the debug render pass to be tone mapped or added after tone mapping. Yeah, I think so. So we tone map here. Post effects. Let's just do that for now. Yeah, everything gets white. That's perfectly fine. Sorry about the flashing. Okay, let's see. So let's see. Can I actually transition or well, or do I want, well, I'm unsure how to access the render target. Let's see. Let's see. So I need to Okay. Could I transition the current back buffer? I mean, this is end frame here. It's still supposed to be a render target, right? But I also want a... Okay, so we can definitely write to it as a render target, but can I use it? Can I use... Okay, let's try it. Let's try it. Okay, so in our root signature, I have an SRV. Wait a minute, I can't bind it as a texture, can I? I can only bind it as a buffer. Oh yeah. I need a pointer. As far as I remember, right? I'm unsure. Let me just look it up. I guess we have to create a... Let's see. I'm pretty sure I can't bind this. So I'm pretty sure I can't bind it, but yeah, so if I do something like, not this, but sit, uh, shader resource view as the first index, right? And if I do something like swap chain get current buffer dot, I mean, this is probably not what I'm allowed to do, right? No, definitely not. Non-buffer, yeah. Yeah, so I actually need a indirection, a level of indirection. So let's do something like this instead. Number of descriptors 1, register space. There we go. And let's do like this. There we go. And let's do let's see, parameter 1. And let's delete this. And let's see how many errors we've created. Okay. Did we have any errors? Yeah. Yeah, we can't do that. Let's see. Do I actually need to create a empty what do you call it? Do I actually need to right now if I disable this, we'll be back, right? Yeah, to the non-tone mapped stuff. Okay. So I need a way to, well, maybe I should just render to a different texture then. Yeah. Yeah, let's just do that. So when I set our clear buffers here, I could what do you call it? Set a different render target. Then our current swap chain. Yeah, so we basically save the swap chain stuff until we actually are ready to apply post effects. And a pass-through buffer will just use point sampling to sample each pixel and pass it through. Well, I guess we can do that. So we need some kind of like function like this. Also, yeah, we don't need to do this. We don't need to clear the depth stencil, but we want to clear the render target. And let's maybe just do a null pointer here. Let's not write any more depth stuff. Maybe just disable this. Okay. Yeah. So up here, after I did the other stream, I actually implemented another render target view. Which allows us to render our whole scene into this texture. Also, let's see. Descriptors reserved. Can I find where? So when we create the textures, so whenever we create a texture, yeah, we offset by the descriptors that are reserved to system textures, I think. So am I not correct that the first one is the shadow map, and the second one is probably the cube map, right? Yeah. And then we could create a third and fourth one. Oh, I just swapped the render target, right? Yeah, I did. Let's just... No, I didn't. I didn't yet. I didn't change anything here. And let's disable this for now. We won't be doing that. Okay. So that's fine. Let's see. 0 equals shadow map. 1 equals cube map or skybox. 2 equals off render target input texture to post effects 1. input texture to post fx2. Let's see, render target 2 slash, there we go. So let's create a create shader resource view. The SRV here, get view, no, get, and the SRV get view. Oh, I need to cast it. And then custom, no. This one gets CPU handle, and then it's the third one, right? Yeah. Okay. Does this all work? Yeah, still good. Okay. So we have our thing where we actually are able to do like this. And let's do a custom RTB heap get handle CPU handle. I think it's, is it 0 or is it, can't remember. So CPU handle 1. Okay. Yeah, so now let's render to this render target here. We should probably transition it right now. It's already ready as a render target. Okay, next we can actually transition it. Let's see, let's grab it down here. And we need this. Let's see, is it get? Yeah, I need to pass that in, and it's a render target, and then it's supposed to be all shader resource here. Whoops. I've made a mistake somewhere, haven't I? Yeah. Anyway, we transition this. And then we transition it from the this state until into the render target again. Okay. Let's do a clear color here, and let's get the render target view here. And let's clear it. And let's see what happens. But now it's not whining about anything. Okay. Stencil format. Okay. I should have found something with zero stencil, depth stencil. I mean, not in root signature, in here. It shouldn't have a no draw instanced. So what happens after we call this? Debug render pass. Okay. So maybe this actually needs to be after this, but well, yeah, this doesn't fit because okay, let's set the handle here, but let's not clear the depth. But yeah, we do not write any depth values no matter what, I think. So yeah, this should be fine, right? Then we can add our depth stuff for our stuff here, and you can already see we're starting to kind of like render some stuff again. Okay. So we're back to the white thingy, and let's bind a descriptor table before we do it. And it's the first parameter, and let's get the third one and the this one. Wait a minute. It's not initialized, but yeah, it hasn't been initialized. This should have been initialized. Yeah. Okay. So inside our pixel shader here, we do a texture 2D. What do we call it? Rendered texture 1. Just T0, right? And let's grab a sampler as well. Point wrap. And let's simply steal the sampling method. Float for color. There we go. And this should just be a pass-through. There we go. So we basically now can do tone mapping. We can, for instance, have our colors or divided by 4. So we have different post-processing effects here. Okay, so that's great. We basically have a tone map post effects pipeline here. And we're ready to do regular tone mapping. Yeah, we could use our root signature to set some root constants. Yeah. Next will be a we will be adding one or more extra render targets to our normal passes so that we can, for instance, do brightness calculations and bloom. Also, I want something called a heat map just for fun. Yeah, but yeah, you definitely want something more interesting going on in your tone mapper here. We could implement, for instance, a normal saturation version. Pass-through code. Uh, Saturate. Normal post effects. Normal stuff. Let's do float. HDR color. Sample. Let's do the sampler point rep. Input UVs. And let's do a float 3. Saturate. HDR color XYZ times 1 return float 4 SDR color dot HDR color alpha. So this is a saturation version. And let's try reducing the exposure here. Yeah, so it basically takes less and less light in. We could set the exposure very low. And our scene suddenly gets very dark. Anyway, I think I actually did some stuff here that I don't want to continue doing. And yeah, pixel shading is pretty expensive, so we're starting to see a toll on our actual frame rate. Yeah, but anyway, this is almost it. I guess let's do the Reinhardt implementation. Yeah, I have. Yeah, I have. Okay, let's do the Reinhardt version. Let's do this, but not this one. Let's do a float 3 tone map Reinhardt with a float 3 factor. Let's just return a float 1 for now. Reinhardt, tone map Reinhardt. Normal exposure here, and let's return this again. Reinhardt version. Yeah, I know. I just, I got carried away. Uh, Okay. Now, doesn't that look great? Actually, I like this tone mapping here. Let's try swapping back to the old saturate one. Well, it's basically the same, it seems. At least for now. Tone mapping takes colors that are out of range for a normal display and remaps it into a normal display range, but it conserves the colors. And it basically allows you to do HDR rendering as well. If you have a TV with HDR, you'll know what I'm talking about. Anyway, we're getting ready to end the stream for today. We're kind of like set up to do bloom, as it's called, and different post effects. So yeah, that's great. It's the build icon, so whenever I click that, it kind of like activates the whole thing. A build menu of sorts. Yeah, but that's it. I'm gonna go to bed. I'm really tired. Thank you, man. I'm gonna play around with the tone mapping stuff and post-processing tomorrow. You too, man. Take care, and thanks for tuning in and chatting with me. It was really nice. I'm just so tired. Hopefully I'll see you around. Bye bye.